itself known in the realm of 3D printing and circuit boards. When I was writing this paper, I kicked it off with a pretty hackneyed story of Steve Jobs and Steve Wozniak in their garage. The story actually starts a bit later than that for me. It starts up in the mid-1990s when I was in primary school and I went through the Dick Smith Circuit Layout Academy. This is probably the same experience a lot of Australian students would have had initially with regards to circuit layouts, and it's terrible if it still exists at all. I spent an entire summer in a tiny dark room with very poor ventilation, craned over, getting massive neck pains, trying to very finickily put together a breadboard and then later on try my hand at a soldering board. It was awful, it was time consuming, and the circuit layouts we did really weren't worth the effort at all. I lost an entire summer. I'm never getting that back. It's gone. And this was the experience a lot of people had pretty much until now with regards to circuit layouts in a domestic or home setting. This is actually what spurned Apple. The reason why this device exists today, or this one, there are your props, is because they discovered, well, Steve Jobs accurately predicted that no one wanted to design their own circuit layouts of the Apple I design that Wozniak had put together. Wozniak wanted to get away for free. And Apple's third, and perhaps greatly overlooked, founder Ron Wayne actually noted this. I've got a quote up there from him. Jobs and I realized that circuits would be the core of Apple. We spent 2 hours around table discussion in my apartment, and I was able to get Woz accept this. The difficulties in lying in circuit layouts weren't reserved for the 1970s or even the 1990s for school students. Problems existed in manufacture of circuit layouts through the 2010s and 2010s. In 2010, Colin Cunningham, he was a circuit layout engineer who wrote for Make magazine in reference to a breadboard, noted he found the process to be very problematic in putting together, and he found circuit layouts to also require a lot of steps. Makers for Hackaday website, fairly infamous in the community, in that beautiful intersection of hacking and also journalism, equally noted that PCB manufacturing at home was not without its difficulties. You'll see in the paper reference they had multiple face-palming moments. Which sort of brings us to the reason why we have Section 21 Circuit Layouts Act 1989 Commonwealth, which is the private domestic use exemption. This legislation was put together in the advent of the signing of the Treaty on Intellectual Property Respect Integrated Circuits, which was never actually enforced, so there you go. The reason why we introduced legislation, of course, was there was a big push during the 1980s when we could go on brown goods in the home, that of course being back then radios and television, not much else, to a broad array of electronic devices in the home environment. And it was felt that there was a need to have protection of circuit layouts, which were essential at that point in time to the international economy. In introducing protections, under the Circuit Layouts Act for eligible layouts that could be commercially exploited, we had durations of 10-year periods. They're still in force today. Section 19, from memory, handles most of the infringement. Section 5 handles most of the definitions of what constitutes an inventor. And sections 10 and 11 outline the case originality, so prior art can't be used to be protected. Section 21, however, I've got the Riot Act up here for you to read at your leisure. This actually has core exemptions for personal, private, and domestic use. If you manufacture a circuit layout in the home environment, that's fine, it won't be considered infringing on an eligible layout. If you distribute to an extent that doesn't actually prejudice the rights of the creator, that's fine too, provided it's not commercial. However, the key here is to an extent. So 1 or 2 circuit layouts presumably being given to your friends of a protected eligible layout is okay. Going beyond that, you might run into problems. And this really results in probably one of the reasons why we have this exemption in the first place is because Lionel Bowen, then Attorney General, noted, much like I did in the 1990s, that chip piracy is not really a problem in Australia. It's exceptionally difficult to do if doing it by hand. He did, however, note that it may be that the Australian chip industry would develop in such a way that more protection may be required. That quote is very important because it's going to be what we call foreshadowing for the next slide. In 2013, some very clever researchers at the Queensland University of Technology came up with a 3D printer capable of printing a circuit board. It's a click and play device. You upload a CAD file with circuit layout, you press play and off it goes. Part of the Kickstarter video, they actually created a game pad you could use with a gaming console. They've most recently rebranded as the Argumentum. You can buy it from their website. They're now based in New York. You can do RFID tags, you can do speakers, a whole range of devices. In its initial Kickstarting campaign, $30,000 was the initial goal. They got to $137,000, about a 450% increase in the original goal. That's how high the consumer demand was. there are enough people out there like myself who realized this device would make life significantly easier. This was actually followed in 2015 by the Canadian Volterra Kickstarter funding goal. They wanted $70,000 for their 3D printer. This is actually a bit of a real game changer, this one. Not only does it actually do the etching, it can actually solder components to the circuit layout. Very cool thing. Now, they received $500,000 of their initial goal of 70K. That's a 120% increase on the original goal. If you look at these two metrics side by side, over a 2-year period, consumer demand on Kickstarter alone increased by 350% for a 3D printer, able to manufacture a circuit layout which doesn't require you to sit over and do this. You can just press the play button, walk away, make a cup of coffee, watch a TV show, come back. All good. We're seeing the same sort of traction in the private sector, business-facing rather than consumer-facing. Nanodimensions is an Israeli-based company. They did a fundraising for their Dragonfly 2020. That's their industrial-size circuit-producing 3D printer. They received $4.7 million in capital funding in June of this year. Their customer base includes defense, transport, and medical sectors. This actually falls in line with Smart Tech Publishing as an analyst firm that does market analysis on research and development sectors. They estimate that by 2022, US, the 3D printed circuit layout economy will be worth in US dollars $428 million. By 2025, 3 years later, it's going to go up to $2.8 billion. That shouldn't be an M, that was my mistake. It's not going to go down to $2.8 million, it's going to go up to $2.8 billion. Here in Australia, close to home, Andrew Pollock is the Executive Officer of Circuit Mount and Circuit Board Association. He's noticed that, he noted in February this year, that we've seen a 20-year decline in PCB manufacturing here in Australia. A lot of the main large-scale ones have been going under, and we've actually seen slight resurgence in the last few years of small and medium-sized firms that are starting to increase their reshoring of work and production of small and medium-sized batch printed circuit boards. Alongside that, he's noted that we're actually starting to see real growth in the innovation sector, which of course 3D printers lend themselves to. They're really great devices for doing rapid prototyping. And he anticipated that if it continues going the way it's going, we may even see an export market for our printed circuit boards in Southeast Asia. So imagine that. So this comes to my research objectives. Number one, balance the rights of the creator with that of the user. Make sure that the people who create the circuit layouts guarantee their proprietary rights, while also ensuring proper access to printed circuit boards remain. We still want to have that technical literacy. This, I think, falls back into what Sam was saying yesterday regarding you want to have technological inequalities for people to be able to manufacture and make at home. And last but not least, and this really goes back, I think, to yesterday in particular, Kathleen, you want to ensure that circuit layouts, improperly pirated circuit layouts aren't circulated. You get a bad rip of a pirated DVD, your sound quality's a bit off, video quality's a bit off, life goes on. You get a bad rip of a circuit layout, you put that into something, you can electrocute yourself and set fire to your house, you can seriously injure someone else who uses it without realizing what's at stake. So we want to balance the rights of the creator with that of the user, the tinkerer, and we want to make sure we can try and eliminate as much incentivization as there is possibly for pirating these circuit boards. The best way to reduce incentivization of pirating is to have freely accessible designs of the protected layout out there. So that's pretty much the idea here, was to research approach methodology. I haven't done anything new here. There were two sort of competing arguments: information wants to be free and protect all proprietary information. I've taken the third approach, which is a balance between those two, very much in keeping with the core Keating era of government policies. That being said, though, there's certainly a lot of room there for alternative methods. So in terms of balancing those, I came up with three major outcomes or results. Of the three, two of them are ostensibly terrible. The third one I think actually has legs. I'll go through the first two terrible ones now in order. The first option is to do an outright prohibition on circuit layout reproduction via a 3D printer. This was actually considered in the 1980s. If you read my paper in the OBITA, there's actually reference to copyright reform bill, where they were actually looking at recordable devices, mostly tape decks back then, and introducing spoiler devices you couldn't actually reproduce audio works. Underneath this sort of model, you could still have Section 21 applying, but you just wouldn't apply with 3D printers. You could still have someone go to Dick Smith's Circuit Layout Academy and hunched over like this in a poorly ventilated room. There's a disadvantage of this. First and foremost, it would ideally penalise Australian home users versus their international counterparts. We try to promote technological literacy here. It would seem a pity to give our innovators and our creators tools which are ostensibly now outdated. compared to their international counterparts who could be using new devices for wonderful new ends. The second issue here is too, it would be difficult to enforce. This is the same problem they actually had with home taping for audio records back then. 3D printers lend themselves to a variety of multiple reproductive uses. It'd be very hard to target one in particular and actually make smaller devices for that. What that means then, therefore, is the only really way you can enforce this is have a police officer standing next to everyone's 3D printer in their home to make sure they don't try and 3D print anything unfeasible. And third, it would result in prohibition of circuit layouts in the public domain. Keep in mind, it's only a 10-year exemption period. Any circuit layout manufactured in 2005 or thereabouts would be fine now for reproduction. So as a consequence of that, you could be unduly penalising people who are using any circuit layouts that actually are in public domain, and we don't want to do that either. The second option, still terrible, a bit better, is to put levies on the sale of 3D printers and the associated filaments which may be used for the production of circuit layouts. This is actually very much in keeping with the blank tape levy scheme that the Hawke-Keating government introduced. That was their alternative to outright prohibition on reproductive or recordable devices which reproduce works. The blank tape levy was essentially, you would pay a levy when you bought a blank tape, like a cassette tape. That would go to a collection agency, which then distribute that amongst all the audio recording holders. That being said, there are a few disadvantages here with this model. The first is increase the financial barrier to entry of 3D printers and their associated filaments to Australian consumers versus international ones. 3D printers are significantly lower cost if you look in terms of historic price point compared to computers at about this point in their development. But that being said, we have just gone through a financial crisis, and whereas we're doing a lot better than most people, Australian households are not what could be described as doing perfectly well. So we're trying to get that price point down to reduce the friction points, the introduction of Australian homes. The other issue here too, of course, is that new filaments may be introduced to the market which aren't put in this levy scheme, which can be used for reproduction of circuit boards. What that means is you have inconsistent application of such a scheme, which is not ideal because you want to have universalization of your regulation schemes. The only way to do it would be to slow down the entire process of release of filaments to the market with increased government testing. This increased costs, increased time for bringing products to market, and again, the people who suffer these consumers. In addition to this, 3D printing lends also multiple variety of uses, which include reproduction of a variety of things which don't include circuit layouts. The Circuit Layouts Act is a sui generis scheme in nature. It needs to always be kept in mind. There's very little literature on this. It hasn't really been touched in any significant degree since it was introduced back in the 1980s. So you can have a lot of people who buy 3D printers, doesn't logically follow they're going to infringe on circuit layouts. So it seems more unfair to penalise people financially, so they may even do. And last but not least, this is moving into the realm of taxation and constitutional law, so I will keep it short. But this actually may be used as a tax, and if that is the case, it can be struck down, like the blank tax levy was. I can go into the question time. I actually cover this in the paper as well. But it's really particular areas of taxation and constitutional law. The third option is putting a royalty scheme based on the CAD files themselves. Under this option, licenses structured for the actual CAD file, which could be sold from an online store, might be an option. And in that situation, you could actually have some royalty goes back to the creator, and then it can be used by the person. The added benefit to this, of course, is they have access to the master copy, which means they don't have the same issues and risks associated with using a faulty copy for the circuit layout. So there are some benefits with this scheme. Of course, it preserves the rights of the creator. It allows the private and domestic use to continue, so we still preserve that. You can still tinker and change and play with designs. And keep in mind, this is only for those that are eligible. Prior art will still be fine. Mitigates the risk of injury through replication of pirate copy, and it's easily searchable. There's the other one too. So one of the problems with the Circuit Layouts Act is Section 21, commercial infringement. If it's by accident, you don't know it's there, you can actually end up being penalised. So you don't have the same issue of unintended infringement because you can readily search and say, oh cool, there's the design, okay, great, we're not going to have to worry about any ongoing problems there. So in terms of conclusions, there were three. The first one was prohibition of 3D printed PCBs. It's unviable, it's a terrible idea. Conclusion number two, levies on 3D printed filaments is also unviable for the same reasons. Also may come across as a tax, so probably not worth pursuing. Conclusion three, structuring royalties on CAD files looks to be pretty viable as it is. In terms of next steps, there are some technological challenges to implement this. It's not just legislative, it's also technological. Two options exist, conventional DRM and permissioned blockchaining. These are not exhaustive, may also be others as well. Conventional DRM is widely unpopular in a variety of consumer rights issues. It's Involves watermark and CAD codexes with a checksum or solely alphanumeric from which you can reference against. Disadvantage is that it can be taped tablets raised to crack and then circulate online, which goes back to the pirated issue. It may be unviable as it extends beyond the creator's rights. The creator may actually say, look, I don't mind you using certain circumstances, but they can't actually regulate that, so it goes to the reseller instead. It may also abolish the first sale doctrine, which is a very important element of consumer rights, where if I sell something to someone else, they can then on-sell that, and that's fine. But with DRM, you can't really on-sell that. It also may result in price fixing on international and regional markets, and it may also result in third-line forcing if someone is, say, a collection agency from overseas, which is compliant with Australia with certain layouts protection, but they want to jack up the price. This is the Australia tax we know from other digital products. The last option is permission blockchaining. It's already considered for practices beyond cryptocurrency. The IEEE had a forum on this back in June of this year for use in pharmaceutical supply chains, so to allow for the observation and monitoring of a lot of precursor substances to make sure they go when they're needed. The standard for framework of blockchain use in Internet of Things, project P2418, was also approved in June of this year. This also looks at using smart contracts and permission blockchaining. Permission blockchaining, of course, being where only several people hold the register. In this situation, it could be the rights holder, it could be the vendor, or it could be a government regulator or similar agency. The advantage of the blockchain, of course, is difficult to tamper with. The creator's rights can be preserved via smart contracts. It preserves the first sale doctrine, so you can on-sell because there's an authentic copy, because it's already been purchased beforehand. Royalty rights may expire at the end of the protection period. It's easy to conduct product recalls if the circuit layout is faulty. We just go back to the register, at least theoretically. And we easily show evidence of and prevent regional price fixing because we can actually look at how that checksum flows between different jurisdictions. So that more or less concludes the presentation. Thank you for your time.